Alright, so problem number one, you roll a die 5 times, and the first one is a 1, the second is a 2, and so on. All of that junk doesn't matter. What is the probability on the 6th roll you roll a 6? Well, same as any other roll, 1 out of 6. What properties does any probability distribution need? Well, there's two of them. Number one, all of the probabilities need to add up to 1. Something must happen. And probability number two, all probabilities have to be bigger than or equal to 0, because you cannot have a negative probability. For problem number 3, event A is equal to 0.3, event B is equal to 0.2, and they are disjoint, which means they don't happen at the same time. So, if they don't happen at the same time, the probability of A and B is equal to 0, and the probability of A or B is equal to 0.3 plus 0.2, which is 0.5. Alright, in problem number 4, we got the same thing, with probability of A equaling 0.3 and the probability of B equaling 0.2. And this time, instead, they're independent, which means that one does not affect the other. So the probability of A and B is equal to 0.3 times 0.2, which equals 0.06. Probability of A or B is equal to 0.3 plus 0.2, except this time we have to subtract off the 0.06 that got counted twice, which gives us 0.44. For problem number 5, you're rolling 2 dice, which means the possibilities are 36, and the only combination that adds up to 2 is 1 and 1, so we got 1 out of 36. If you roll dice many times, about 1 of 36 will be a 2. Now, it's not exact because there's randomness, but you gotta roll a bunch of times. For problem number 6, probability that June gets hired is 0.6. Probability that Duran gets hired is 0.3, and probability of J or D equals 0.7. What's the probability J and D both get hired? So the probability of J or D is equal to the probability of J plus the probability of D minus the probability of J and D. So we know that the OR is 0.7, we know J is 0.6, we know D is 0.3, and we don't know the AND. So 0.7 equals 0.9 plus, when we put these together, minus the probability of J intersect D, minus the 0.9 on both sides. Negative 0.2 equals negative probability of J and D. Two negatives become a positive, and there's our answer. 7. Two disjoint, mutually exclusive things that have to do with numbers. Even numbers and odd numbers. Positive numbers and negative numbers. Numbers above 50 and negative 2. So here's 1, here's 2, here's 3. So there's 3 sets. Okay, problem number 8 is another one of these describing what happens, and so over a large number of at-bats, about 30% should be hits. Alright, so what is the probability that none of the next 3 at-bats are a hit? Well, the probability that the first one is not a hit is 0.7, because either you get a hit or you don't get a hit, times 0.7 for the second one that's not a hit, times 0.7 for the third one that's not a hit. Now, the one thing we're assuming here is that these are each independent, and we get the answer of 0.343. And that's the answer for B. So problem number 9, they want us to make a Venn diagram for dogs and cats. So, probability that they both own a cat, or I'm sorry, that they own both a dog and a cat is 0.12. The probability that they own a dog and not a cat is 0.13, so that circle can add up to be 0.25. And the probability that they own a cat and not a dog is 0.06, because the cat circle has to be equal to 0.06. And so I'm going to do 1 minus 0.13 minus 0.12 minus 0.06 to find out what percentage of people don't own a dog or a cat. And that would be 69%. So B, find the probability that a family owns a dog or a cat. Since I have the Venn diagram, I'll use that. I'm going to add 0.13 plus 0.12 plus 0.06, which turns out to be 0.31. C is asking for someone who owns a dog or doesn't own a cat. So these people own a dog, these people own a dog, and these people don't own a cat. So 0.13 plus 0.12 plus 0.69 equals 0.94. And D, find a dog owner who doesn't own a dog and doesn't own a cat. So because we're doing doesn't own either one, those are the people on the outside, which is the 69%. For problem number 10, if you choose any student at random, what is the probability that is a male? So there's 20 males out of 50 people, which gives me an answer of 0.4. B, if we choose a student at random, what is the probability he's a male if we know that the student prefers sports? Well, there are 16 people who prefer sports, and that's what we know. And then we have 10 males out of those 16. So we got 10 divided by 16 is 0.625. Problem number C, we have males and prefer movies, and we want to know if they're independent. So we have 20 out of 50 who are male, and we have 8 out of 16 who prefer movies. Sorry, try that again. That's not right. We have 16 out of 50 who prefer movies. And if these are independent, how many people are both? And that would be 8 out of 50. So 20 out of 50 times 16 out of 50 is 0.128. And 8 divided by 50 is 0.16, which means that these two things are dependent, because when we multiply the probabilities together, they didn't equal the intersection. Okay, a movie theater has 35 people in it, 21 girls and 14 boys. Manager picks out 2 random students for free candy. What is the probability that they are both girls? Well, the first one would be 21 out of 35. Now, once we pick the first girl, there are only 20 girls left out of 34. So 21 out of 35 times 20 out of 34 is 0.353. And then for part B, if we know that the second student chosen as a girl, what is the probability the first one is a boy? Well, if we take out one of the girls, it doesn't matter whether it's the first one or the second one, but one of the girls has already been chosen. We have 34 students left, and all 14 boys are left to be chosen. And 14 out of 34 is 0.412.